how we've worked on the performance of Angular Universal. So we'll be talking about universal performance. Again, my name is Justin Appler. I'm the lead front-end engineer at Crunchbase. And let's first start by talking about what Angular Universal is, just in case nobody's familiar. So Angular Universal is a mechanism to make your single-page application behave kind of like a multi-page application when first load. So it allows you to do server-side rendering of your Angular application, which is basically adding Node.js to the list of browsers that you have to support to a certain extent. It also lets you respond, importantly, it lets you respond with fully formed HTML and content instead of just that entry component tag. So if you're only using the client-side version of Angular, this allows you to boot up directly with that when you sit in the browser. And there's a couple reasons that this is useful. The first one is you can improve your first meaningful paint. So what is first meaningful paint? This is the first time that the user sees content that is what they were trying to see, right? It's the meaningful, useful information for them. And the reason it's faster using Angular Universal, if you're using it properly, is that you can actually let the browser start rendering HTML and CSS before your JavaScript runs, right? So instead of seeing that white screen until all of it executes, you instead see this content. And I don't have time to really go into all the reasons having that first meaningful paint be faster, but there's plenty of them. And it involves better conversion rates, it involves better engagement, lower bounce rates. There's a whole host of reasons why it's useful. And Angular Universal allows you to do that. It also helps you improve your search engine optimization. So this is a graphic from Google I/O last year, and it's talking about how the Google search crawler works in these multiple stages. So when it finds your website, it's going to first do that first wave of indexing. So it's going to download the HTML by requesting your site. And from there, it's going to look for links, it's going to look for semantic content, anything it needs to index the page. But if there's JavaScript to execute, it's going to defer it. It's going to do it later. And that can be a couple hours later if you're lucky, or it can be weeks later, or potentially never, right? If you have a site with a lot of pages, it may never get to actually running your JavaScript. So the content may not be available the same way that it would be if you had served it in the initial HTML. The last reason, it allows you to use Open Graph and things like schema.org. So if you've ever copied a link from a website, pasted it into Twitter or Facebook or something like that, and all of a sudden you get this nice graphic with an image that was on your page, plus the description, the title and all that, that's using things like Open Graph tags. If you're just using the client version, you really kind of have to specify one for your entire site, right? You have to say, I am crunchbase.com, as opposed to, I am a certain thing within the site, and making it more available. So Universal enables that. That said, just using Universal does not make your site faster, right? Like a client-side application, you have to optimize it and understand what it's doing in order to get the performance benefits that you want. So let's talk a little bit about performance server rendering, right? How you make Angular run well when it's on Node as opposed to the browser. So first off, optimizing for the server is very different, right? So on the client, a lot of what we do is deferring. We want to defer execution to a different frame. We want to make sure that the frame rate is high. So the key metric we go for is frame rate. Is there jank? Is there an animation that doesn't look quite right? You want it to be smooth and clean and the user to not feel like they're moving slowly through an application. On the server, it's kind of more about condensing. It's more about doing as much as you can, as quickly as you can, execute it all at once, limit any async operations, anything where you're going and fetching data and you don't know how long it's going to take for it to come back. And your key metric becomes response time. It's that time to first byte. So you request the home page or a web page, how many milliseconds go by before you get HTML back? And so that's kind of what you're targeting. The good news about optimizing on the server is that you can use some of the same tools that you know and love on the browser on the server as well. So this is an example of the Crunchbase homepage on my developer machine, just using the node -- inspect flag. And kind of the key point here is I can't give you the answer to solving performance in Angular Universal, right? You have to go look into what your app is doing and understand it, and that's really important. There really isn't a one-size-fits-all solution to good performance on the server. So here's some one-size-fits-all solutions to performance on the server. So let's kind of go back to what I was showing before. We have on the left side, you don't have to really see what's going on here, but we have an incoming request, and then we have the Angular application booting up, and then we have this big gap, and that's the big line with the question marks. And then you have the right side, which is the Angular application doing a little bit more rendering, and then finally serializing everything that's rendered as HTML and shipping it to the client. Does anyone have a guess what happened in between? Why there's a gap? External call? Exactly. So what happened was this, right? A request came in, we started executing JavaScript, then we went out to get data, we went out to get something, and when it came back asynchronously, we continued executing that JavaScript. So this looks pretty good. You'll notice that all three of these boxes are pretty close together. And the total response time, there isn't one, but it kind of feels okay, so that's good. The problem is when the second request comes in. So if that second request comes in right after the first request, let's say, it's going to try and start executing on that same server. And we're going to get something like this. So if we kind of follow this through for the second request, the first thing it has to do is wait. It has to wait until the first request gives back the CPU. So that red box over here is kind of just wasted time. That's wasted milliseconds that aren't particularly useful, nothing's happening. Then the data request happens for the first request. This is async. Now request 2's JavaScript can start to execute. But then the data comes back for the first one, and then there's wasted time while the first one is waiting, and then the second one. And you can kind of see how this can become a problem. And this is the classic case of two requests contending for the CPU, right? Fighting over the CPU. And there's a couple good ways. There's no easy way to fix this, but there are some good ways to kind of prevent it and slow it down. One of the things that makes a lot of sense is keep your servers at a slow utilization, or a low utilization, right? One of the things that's worked really well for us is having fewer machines with more CPUs and more power, essentially. So instead of just throwing more and more machines at it, actually focus on the performance of those CPUs and how many you have. And then you can combine that with tools like Cluster in Node.js to ensure that there's one server per CPU. And when you combine those two things, you now have a system that can handle a lot more requests without getting into this contention. And the final piece here is avoid round robin. So like almost any proxy or gateway that you use to route requests to your node servers is probably going to default to some sort of round robin request handling, right? 1, 2, 3, 4, 1, 2, 3, 4. That works well in a lot of cases, but it does not work well when you're worried about this issue of what happens when one process has way too many requests to deal with. So if you use more of a least connections approach, and this algorithm is in a lot of different gateways and proxies, you'll have a better chance of the process that you get having very few things going on. So that will go a long way. So now let's take a look at a piece of code that's running on the server. Does anyone have an idea as to why this might be problematic on the server? Yes? It's waiting on user input? Okay. That's actually a really good point. What else? The 400 milliseconds is kind of the key here. So fortunately, there's no user input, so it's not going to actually trigger, but the start with is kind of imitating that actually. So an input is coming through, it's going to wait 400 milliseconds until maybe something else happens, and then it's going to be done. And so this very simple thing that probably exists in your client code in a lot of places, just set a 400 millisecond floor on your response time. It's never going to be better than that, because it's always going to sit there waiting. This one comes from experience. So what does this mean? Watch out for delays on the server. Again, going back to that idea of condensing, anything that's deferring or waiting for something to happen, or a debounce or a throttle, it's going to give you problems. And this is kind of one of those places where you're probably going to want to have different logic for the server than the client. Also, consider timeout. So if I have an HTTP request on the client that takes 10 seconds or 15 seconds, it's not ideal, but I can do something to let the user know I'm doing something. When that's happening on the server, the only thing that you're showing them is a white screen. You're not actually giving them any information. So if you have something that's going slow, make sure you have a timeout in place that's going to say, cut this thing off before it goes over maybe only 100 or 200 milliseconds, and we'll try again on the client to load it. So generally, watch out for delays in server code. Another thing to remember is, because you have this Node.js server that has memory that's persistent, you don't always have to create everything from scratch for every request, right? An Angular application loads in the browser, it has to boot up everything and get all the things that it needs. So in the first example here, we're just doing some slow operation. But this is executed for every request, or in the case of on the client, it's executed every time somebody opens a new tab. But if that code is, or if the data that comes back is immutable and is constant for all users, there's really no reason to do it every single time. And so this is one of those cases where if you find yourself, if you're kind of profiling your application and just seeing the same stuff over and over again and kind of wondering why it's in so many places, it could be something like this. And then lastly, server-side rendering is not right for everything, right? So it's really great for making crawlers happy and making your users happy because you're giving them something to see fast. But there's a lot of stuff that users don't see immediately and crawlers can't see at all. Video players, charts, ads, icons, anything below the fold, right? You may decide that I'll load the bottom half of my page later, just to get something in front of the user as fast as possible. The one thing to remember there, reserve space. It's a real bummer when the page is loading and it just keeps changing as things load. So it's really nice to reserve space so the layout remains constant. And it's really good to build, instead of just kind of having these if browser statements all over your code base, you can use like very simple components that allow you to kind of define these things declaratively. So the next developer that comes along understands, hey, this piece of code, it's never going to execute on the server, just on the browser. And this can go a long way to getting that time to first byte down even lower. And that broadly is some of the tips that we've learned over the last 2 years of using server-side rendering at Crunchbase. And that's it. Thank you.